Hi, today I come up with a new interesting topic that is IBM QRadar SIEM Basics and Deployment Guide. Introduction to the Security Monitoring and Deployment Steps. IBM QRadar SIEM Fundamentals. Overview of IBM QRadar SIEM Centralized Threat Monitoring. QRadar consolidates security logs and network data for real-time threats detections across diverse enterprise systems. Custom rules engine. The custom rules engine correlates events with predefined rules to identify and group potentially security incidents effectively. Threat intelligence integrations integrates internal and third-party threat intelligence to enrich events with indicators of compromise for enhanced detection. Compliance and scalability supports compliance reporting and scales from small to large distributed environments with flexible deployment options. Core QRadar architecture. Key QRadar components and their roles. Component, primary function, key benefit. Console, central management, UI, correlation offenses, single point of control and visibility. Event collector collects and parses log events, reduces WAN usage and central load. Event processor processes and correlates events, high performance threat detection in key benefit. Flow collector slash processor captures, analyzes network flows, deep network visibility in key benefit. Data node, extended event and flow storage, improved scalability and search. App host runs QRadar applications, isolated and stable app execution. QRadar data processing, event and flow data collection and correlations. Event data collections, events are log records from systems like firewalls and applications and collected and normalized for consistency. Network flow data. Flow data captures the metadata of network communications, including source, destination, ports, and protocols. Data correlations and offenses. QRadar correlates events and flows to be detect suspicious patterns and generate aggregated offense incidents. Enhanced detection features, behavioral analytics, profiling, and references sets improve detection accuracy and context awareness. Deployment models. QRadar deployment architecture options. All-in-one deployment. All-in-one model combines console, event processor, collector, and flow processor on a single appliance, ideal for small to mid-sized setups. Distributed deployment. Distributed deployment separates workloads with dedicated event collectors, processors, and data nodes, enhancing scalability and fault isolation. Geographically distributed operations supports remote event collectors at branch offices for local log collection with centralized management for global visibility. High availability and deployment flexibility. High availability ensures redundancy for critical components. Deployment options include physical, virtual, and cloud appliances. Capacity planning, sizing, EPS, and storage considerations. Events per second (EPS) is the key metric representing sustained event processing essential for capacity planning in deployments. Flow collection capacity. Flow per minute (FPM) helps size network flow collection and processing to ensure visibility and performance. Storage and retention. Storage planning considers retention policies driven by compliance, forensics, and reporting requirements. Resource monitoring and scaling. Regular monitoring of CPU, memory, disk, and network bandwidth ensures optimal performance and scaling. Installation and setup. QRadar installation and initial configurations. Deployment options. QRadar can be installed on physical appliances, virtual machines, or cloud platforms to suit organizational needs. Console setup. The console serves as a CIM foundation and is configured with network, time, licensing, and system settings through Wizard. Adding managed host. Additional components like event collectors and data nodes are added via system and license management for expanded monitoring. Post installation tasks. Tasks includes log source configurations, event passing verification, network hierarchy setup, asset definition, and NTP time synchronization. Post deployment operations. Tuning, monitoring, and administrations. Rule tuning for accuracy, adjust rules and correlations logic to reduce false positives and align with organizational risk tolerance. System health monitoring, track EPS, disk usage, queue backlogs, and managed host status using built in dashboards and notifications. User and role management apply least privilege principle to manage user roles and access for analysts, administrators, and auditors. Backup and version consistency. Perform regular backups and maintain version consistency to protect data and ensure system stability. Best practices. Operational and security best practices. Software version consistency. Maintaining consistent software versions and fixed packs prevents errors and ensures systems reliability. Content updates and threat detections. Regular updates of TSMs and rules keep passing accurate and threat detection current. Incremental log source onboarding, adding log sources gradually allows for validation and rule tuning to improve data quality. Network segmentation and monitoring. Careful network segmentation and firewall rules reduce exposure while allowing necessary communications. Performance monitoring and capacity planning. Tracking EPS and FPM trends helps plan upgrades before performance thresholds are reached. Documentation and training. Documenting the architecture and procedures supports audits and ongoing staff training improves threat response. This is the last slide for today's interesting topic. Thank you.